Today we're going to solve absolute value equations, including absolute value inequalities. Now remember that absolute value is a measure of distance. So the absolute value of x, if it equals 1, we're saying that it's 1 unit away from 0 on the number line. So 1 unit away from 0 would obviously be 1. But we got to remember about this guy here, the negative 1. So if we have the absolute value of x equals 1, it actually would be x equals 1 or x equals negative 1. Whenever we take the absolute value of a number, it just makes it positive because we're measuring distance. So what if we had something a little bit more complicated, like the absolute value of b over 5 equals 1? Well, we need to set up two separate equations. We need to set up the b over 5 equals 1, but also the b over 5 equals negative 1. Just like x equals 1 or x equals negative 1, we do the same thing here. We take everything within the absolute value, we set it equal to the positive number, and then we set it equal to the negative number and solve each equation separately. So to get rid of the fraction, we multiply by 5, and 1 times 5 is 5. We do the same thing over here. So when we solve this equation, b could either equal 5 or b could equal negative 5. If we plug them back here, 5 over 5 is 1. Take the absolute value of 1. That is, in fact, 1. Negative 5. Negative 5 over 5 is negative 1. And the absolute value of negative 1 is positive 1. So we did do that correctly. We checked our work and it is perfect. Something a little more complex here. Alright. So again, we set everything in the absolute value symbols equal to 16. And negative 16. We set it equal to 16 and negative 16. We solve each equation separately. This cannot be simplified anymore. So x equals 4 or x equals negative 12 fifths. So you're not always going to get the same number like here. We got positive 5 and negative 5. Over here we got 4 and negative 12 over 5. So I want you to see that you might get different numbers. They won't always be the same. Alright, let's look at another example here. So now we have three minus the absolute value of 8x minus 6 equals 3. 3 plus. 3 plus the absolute value of 8x minus 6 equals 3. So what I'm going to do is subtract 3 from both sides. The reason I'm doing that is I need to isolate the absolute value symbol. So that's all that we have on this side of the equation. Move everything to the other side here. Now in this case, we have the absolute value set equal to 0. There is no positive or negative 0. There is just 0. So in this case, we only set up one equation. We're only going to have one answer. When we have a positive number here, so like positive 16, we got two answers. When we have a 0, we're only going to have one answer. So we're going to solve this equation just like we normally would. And we get x equals, these are both divisible by 2, so x equals 3/4. We only get one answer. When we isolate the absolute value and it's equal to 0, we only have one solution. Let's look at one more example with this, and then we'll look at inequalities with absolute values. Alright, so now we have again, we have to isolate the absolute value, get it all by itself. There we go. So you remember we took the absolute value of a number and it becomes positive. So right here I have 15, the absolute value of 15x equals -4. Whenever you have an absolute value equaling a negative number, there is no solution. There is nothing you can make x that you could take this absolute value of and make this a negative number. There is no solution when you have a negative number equals an absolute value. That is not something we can make happen. Alright, so let's look at a few inequalities here. So let's just talk about inequalities and absolute values. What happens when you put them together? So remember that we're talking about distance. When we're talking about distance, we're saying the absolute value of x has to be less than 2. So let's think about what that looks like on a number line. So I'm saying the distance from 0 has to be less than 2. So again, it's an open circle because it's less than. It's not less than or equal to. So we're not including 2 in the number. So the distance here has to be less than 2. So it has to fall in between the -2 and the +2. All of these numbers in between would give us a distance from 0 less than 2. But if we had greater than, that's going to look a little bit different here. So if we're saying the distance has to be more than 2, then that's not going to include any of these numbers between -2 and 2. That's going to include all the numbers less than -2 and all the numbers greater than +2. These are going to be the numbers that have a distance from 0 more than 2. Alright, so let's see what that looks like when it comes to solving these equations. Alright, so if we have 6n in the absolute value is less than or equal to 18. We need to isolate the same way. We need to isolate the absolute value, but it's already isolated, so we're good. The way you set it up when you have a less than or equal to, you're going to set it up this way. It's going to fall somewhere between -18 and positive 18. Right, because we're looking at everything in between. This is going to fall in here somewhere. So now I'm going to get n by itself, and to do that I need to divide 6. So I'm going to divide it from all three, make every single part equal. So then I have negative 3 is less than or equal to n is less than or equal to 3. So let's look at that on a number line here. We have negative 3, we have 0, we have positive 3. We're going to do closed circles at negative 3 and at positive 3. And n is somewhere in between. Perfect. So let's look at another one here. The absolute value of m minus 2 is greater than 0. So remember, we have to isolate the absolute value before we do anything else. So now I have the absolute value of m is greater than 2. So the way we set up an absolute value with a greater than or equal to is we say m has to be less than the negative number but greater than the positive number. Because again, we want the distance to be more than 2. The distance is more than 2. So then I just go ahead and graph this here. Open circles. Greater than 2, less than negative 2. All right. Now remember, we need to isolate the absolute value. So I have 4 times the absolute value of 6 minus 2a plus 8 is less than or equal to 24. So the first thing I'm going to do here is subtract 8 from both sides. Remember, I do subtraction and addition before division and multiplication. When I'm trying to isolate your variable here. 24 minus 8 is 16. Now I divide out that 4 to get the absolute value by itself. So now I have, this comes up here, the absolute value of 6 minus 2a is less than or equal to 4. So now that I have my absolute value isolated, since it's less than or equal to, I'm going to do negative 4 is less than or equal to 6 minus 2a is less than or equal to 4. And now I want to isolate the a, so I subtract 6, and I get negative 10 is less than or equal to negative 2a is less than or equal to negative 2. And then I divide by the negative 2. And remember, since I'm dividing by a negative number, I'm switching the signs now. So now I have 5 is greater than or equal to a is greater than or equal to 1. So now I have 0, 1, 2, 3, 4, 5. So now I have 1 and 5, and A is in between. Alright, and if you want more practice other than what we're going to be doing in class, of course, you can go to IXL, go to the Algebra 2 tab, and then sections B, 4, and 5 will help you get more practice in this area. See you in class.